in the market, mass produced or is it not mass produced? Okay, so sometimes the drop in price is because we understand technology very well, and sometimes it's because there is a high demand in the market, and therefore we can mass produce it and reduce the cost accordingly, right? So due to all these different aspects, you will find that when technology has matured, probably a decade earlier than solar. Now, does that mean that you should do wind all the time? No, it depends. If you are in a windy place, maybe you should do wind. If you are in a sunny place, maybe you should do solar. If you are in a sunny, windy place, maybe you should do both, or 50-50, or it depends, right? But as far as levelized cost energy average for different areas, wind is even more mature than solar. Does that make sense? Yeah.
Which is better, levelized cost energy, wind or solar?
No. Today?
Today is?
Yeah. Again, it depends on where you are at. Where are you going to build your project?
In general.
On average, wind is still slightly cheaper, but not much cheaper.
It depends on the location.
Yeah, it depends on the location.
If the wind speed, for example, in area wind speed high, it's automatically wind. If solar, and it depends on location, especially.
Right.
Other things, skilled person and area, and if we include the price of the land, this will be changed. In Saudi, usually is free, but on European country, for example, we need the footprint. It's very, very expensive.
I don't know why you think in Saudi it's free. Saudi land is very, very expensive in some places.
In some places, yeah, Sharqiyya, but in the desert, it's
free.
like,
Yeah, so there are different factors, right? But this chart would show it on average, right? On average. So if you, according to that chart, we are talking about something that looks like this. So the difference is narrowing, and it's narrowing very quickly. Yeah. Again, it's very important that we realize that this is location specific. Now this is based on rotating machine, which is both good and bad. In terms of operationally, usually maintenance cost is higher for something that has moving parts. Wind is very hard to predict. If you are an electrical engineer, wind requires reactive power. Solar requires very little reactive power. But don't worry about that, that's only a side point. It affects how this is connected to the grid. So the requirement to the grid is different from wind than.
Sorry. Usually for the PV, DC, EC, we need the inverter. But for the wind, you can normally DC.
That's what I'm saying.
So
Including your
there are four different types of wind technology. And here I'm not talking about the wind turbine itself, but how that is connected to the grid. How that's connected to the grid. So you can connect the wind turbine directly to the grid, or you can connect it directly but with some control, or you can connect it directly with some electronic devices. It's called doubly fed induction generator. Or you can connect it indirectly with the grid through an inverter. So this would be very similar to the PV system. PV is connected to the grid through an inverter. This is also connected to the grid through an inverter, although the wind turbine will produce AC. So you don't need that. So with all of these three, you don't need the inverter, right? But if you have the inverter, it will give you added benefits. So better control, better frequency response, and so this is there. You rarely see it being done, but everything is there. Okay. The ones that are used mostly are these. The very old installations are mostly type 1. This goes type 1, type 2, type 3, type 4. There is no nice names for these. Very boring names. Okay. Type 1 is dominating technology up to 7 most of the old installations are type 1. Most of the new installations are type 3. So they are grid connected directly, but there is a small power electronic device, a small electronic circuit here that can help you control. Okay, so these are the different. It's wind is AC, so you can connect it directly, no problem. But if you add some additional stuff, then that helps you with actual control and stability.
So by default, wind and solar are directly connected to the grid instead of storage?
Well, when I say directly connected to the grid, I mean not interfaced with anything. So this is not interfaced with anything. This is a wind turbine. This is just a transformer. So it's directly connected to the grid. This is not directly connected to the grid, meaning that this is an interface. So this side is an AC grid. This side is an AC grid, but it is running at a different frequency. PV. So over here, this is optional. You can do it or you can not do it. But with solar, this is not optional. This is a must because this is DC, this is AC. You cannot make them work together. You have to interface them. Now, with all these different technologies, you can add storage, right? So storage is something that can be added to any of these technologies. Mm-hmm.
In terms of storage, is it actually viable? Doesn't it deteriorate really, really fast? And the energy density is very low.
Yeah, I was not planning to talk about storage, but if you want me to, I can. We have 6 other technology types that we have not touched upon, but I can talk about storage.
No,
No.
there's no time then.
Okay, then CSP. So CSP stands for concentrated solar power. This is one form of CSP. There are many, many forms of CSP. One form of CSP is that you have these mirrors. These are normal mirrors. These are not solar panels. These are just mirrors. Okay? And they focus the sun heat into a focal area, a focal point. And that focal point is basically a tank. A tank that is filled with oil or with some sort of material that captures the heat. That heat is exchanged with pure water. Water turns into steam. Steam runs into a turbine. The turbine rotates, you produce electricity. This is very similar to you burn fuel. Fuel turns water into steam. Steam runs into a turbine. Turbine rotates, you produce electricity. From the electromechanical standpoint, identical after you rotate the shaft. It is only a matter of how you rotate the shaft. So if you rotate the shaft by burning fuel, that is a fossil fuel-based steam turbine. If you burn it by the heat that you capture from the sun, that is solar, concentrated solar. Great technology, wonderful technology. And it is so wonderful because when you get the heat to this point, this is a tank. So this is an inherent storage included in the technology itself, as opposed to solar PV or wind. If you want to store energy, you need to add a storage device, like a battery, right? Over here, you don't need to add a battery. The tank is already there.
What do you mean by tank? How can a tank store heat?
Well, it's don't take my word literally. You focus this in a focal point. You capture the heat in
Heat exchanger.
a liquid. Then you can store that liquid, right? Yeah. And then you exchange that heat through a heat exchanger with water. What I want to say is that this is not water. This is not water here directly. This is an intermediate step where you capture the heat, you store it in maybe oil, or there's a number of options for what medium you use.
Usually we use salt mortar because for the oil, for this kind we can reach more than 1,000 degree. For salt mortar we can resist. For oil they will burn after 500.
Yes.
And a lot of study in how to choose the what they call it, the medium, fluid medium or something.
Yeah, right. So that's among the strengths here is that storage is inherent in the process, and therefore this is more predictable, more controllable. You can control how much you produce. You capture the heat, but you don't have to produce electricity right now. You capture the heat during daytime, and then you can produce it at night. So PV you cannot produce at night. Wind you cannot produce unless the wind is blowing. Right? Here, the heat is not there, but you can still produce because you have the inherent storage. But it requires significantly more space for a given capacity. So if you compare a 100 megawatt plant, CSP, compared to 100 megawatt plant solar PV, then this will probably require more space. Okay, so space is an issue here. Capital cost is also still significantly higher than PV, especially with this development on solar PV in the past few years. It is less modular, especially this form of CSP. I mean, there are different forms for CSP, but this form is less modular. You cannot install this in your house. It's not going to be effective, but you can install solar panels in your house. Can you install wind in your house? Why not? Noise and vibration. Right? Vibration. So there is micro wind, but it never was.
Those between houses,
That's also true. Yeah. And usually we don't live in windy places.
Yeah.
People don't like to live in places that are too windy, right? So there are different factors why you don't use small wind turbines. Okay, let's move on.
Excuse me, Doctor.
Yeah.
What exactly do you mean when you say modular?
Modular means that you can build it small, you can build it big. That's flexibility with size. طبعا you can always build it small, but it will, some of the technologies will make more economical sense when you go small, and some of them will make no economical sense. Biomass, you guys have mentioned biomass, right? So with biomass, the fuel is what? Waste, right? The residuals, animal residues, industrial residues, forest crops, agricultural crops. So they grow corn, they get corn oil, and they burn corn oil. There is actually a big industrial.
Brazil.
In Brazil, they do this. In the U.S., United States. So in the U.S., corn oil that people use for what mainly? For cooking. The price for corn oil has increased in some areas because they use that corn oil to produce electricity. They burn it to produce electricity. So farms in some states are very agricultural, right? So these farmers, they are trying to find the best yield for their business, right? So they used to extract that corn oil, and then they sell it to Panda and Fa and Mazra'a, right? And Lulu Market, the equivalents in the US, okay? And now these power plants, they come to these farmers and they say, look, we would like to buy this corn oil, and we're going to burn it to produce electricity, and we'll pay you more than what Panda pays you. So maybe you think the farmer would like more. They will do business with these power plants. So when they do business with these power plants, the price for corn oil has increased, and the availability is less. They are making more money, but the corn oil that you would like to use for your
Also the-
is now more expensive.
The vegetable oil also price. If you check 15 years,
Same
now
thing,
it's
same.
similar.
Unfortunately, biomass power is attributed to very low octane rating, very low.
Mhm.
So unfortunately, moving into this direction is going to be quite a cumbersome. So yes, it is part of the business, but there's so many challenges with regards to the octane rating.
That's true. Now, biomass, I have never seen anybody advocating for using biomass at a very large scale. Yani nobody would say Saudi Arabia, they would like to install 60 gigawatts of renewable by 2030, build 20 gigawatts of biomass. That would be crazy, right? That said, in some certain circumstances, biomass is probably the best. So it's so in a farming, in a agriculture environment, in a place that is not grid connected, isolated areas. Dr. Asst was talking about fuel poverty, right? So if you are in a place that is very far from the grid, and you'd like to find a source for electricity, right? And you are already in an agricultural environment, you can collect this waste and so on. And then you can process it, and then you extract methane that comes out of it, and then you burn that methane and you produce electricity. So at low scale, at small scale, in many cases, this is excellent, this is perfect. But I don't think anybody is advocating for biomass at large scale because of all the different factors that have been mentioned here. Of course, at the end, you are going to also burn a fuel and you get CO2 out of it, right? But the argument is that the CO2 that you get out of this is going to be emitted to the environment at any rate. After this biomass degrades, right? So when agricultural residues, they degrade, they will also emit CO2, right? So you are not adding more CO2 by utilizing them to produce electricity, but you are speeding up, accelerating the process, right? Yeah. So there is an argument over there. Nobody says that this is not emitting CO2, but it is better than probably extracting oil from underground, which is going to be underground forever if you don't extract it and then you burn it, right? So that CO2 will not have been emitted had you not extracted that oil and burned it, right? That's not the case here. Can I finish everything in 5 minutes? Are you guys familiar with geothermal? You extract the heat from underground, right? So just underneath us, this is the crust, and in places where the crust is very thin,